So all we need to do is to dot execute many using this insert into table values. So we're inserting many rows, 4 question marks because we're providing all the data for the 4 columns here. All right, so if you have 5 columns, then you need 5 question marks. And lastly, we just comma the entire list of lists, data values. Very, very easy, very, very user friendly, programmer friendly also. We just basically type across the screen the different column values. You can also, if we had a integer column, we can also just put in the Python's integer. We don't have to convert it into string. And that's the whole point of passing directly the data values here, because then the Python's data type is also visible to this function execute many. Okay, so that's the green part. We're doing the green part and we're doing the green part. Then we perform a commit to really commit it to the database. And we then do a read back. All right, select star from account, fetch all. Now you see here, this cursor dot fetch all is basically saying I previously issued a select. That means I want to read back, right? There may be 10 rows, there may be 10,000 rows, there may be 0 row. All the data would have been stored, retrieved back from the database already by the time we finish this execute function. Then what is needed here is simply to get the data from the cursor's internal memory out into Python's list of lists. So the fetch all is going to return to us a list of lists. Basically, again, it's a list of one list per row. One list per row, right? So basically, we are getting back the same kind of structure as when we inserted into it. Then we do a cursor.close, con.close. Now notice here the commit, let me stress again. I kind of went past too quickly just now. This commit is only available at the connection level, not at the cursor level. So con.commit. So we basically have sort of implemented all the 4 color sections and also performed a create table, smart create table, drop table if it exists, and then perform a bunch of insertions. So it's basically as simple as that. Let's move over to our Spider interface here, Spider IDE here, and just copy and paste our codes here and have a look. Okay. Now, I do want to shrink this a bit to review the Py-on subdirectory. And because mine is unnamed, I really want to change the current directory to d:temp Py-on. Okay, and then be done with it. Okay, so let's see how we can basically move on from here. When I run the connection, all right, let's just run it. Okay, what happened to the connection? It's there. Okay, and well, the table here, let's see. Oh, it's connecting to a different directory. I'm sorry about that. So we need to import OS and force. Okay, force the directory to be changed to my intended directory. So let's close it. Okay, and then we run again. Okay. Now, do you see this accounts.db here? You see this? All right, accounts.db is being squeezed in. Yeah, we haven't even opened the table, but because of the connection, SQLite checks that there isn't any file associated with it, so it creates a new file, a new account, .db file. So what we do now is just simply to close it. Okay, and we can just close the whole thing. All right, Then we can just copy. Well, this is to obtain a cursor, and we talked about having this as an example, create, right? But a better way is to make sure that we are smartly dropping the old table if it exists, and then create it otherwise, right? Okay, so assume that it has been created. We are now then able to populate the table with a bunch of data. Okay, so I'm just squeezing down the font size a little bit so that we can see all the data there. So we can just type it in here, but obviously we can also read in from a text file or a CSV file, doesn't matter. We have a list of lists. Doesn't matter if it's list of tuple or list of lists, it is okay, right? It's no issue there. Um, the nice thing about list of tuple is that because Python strictly enforces tuple to be only read only, it is impossible for hacking code to sort of modify your data because it's not doable via Python. So and another additional layer of safety there for your data. So we want all this data that makes sense to us to safely go through Python, go through cursor, go through connection all the way to the file and reach there and be stored there safely unmodified. Right? So that's the whole idea. Then we insert and we do a commit. Perhaps, all right, let's try this. Then we do a fetch all and we do a print of cursor fetch all, right? And then we are done. So let's run this. We can delete the accounts DB. So we're back to this again. And I like for you to be able to see its creation. Okay, it's really, really fast. You see this accounts popping up. And this part basically is read back in from here. It's so fast, right? It's committed and then it's read back, select, read back, and so on immediately. So we can also say uh, read back data, right? Data lists. Cursor.fetch all. So here I'm modifying from what we see in the slide so that we can also see what is stored here. Now again, I'm going to delete the accounts DB. So we are back to clean state again and run. Okay, good. So we have accounts created, and now we also have captured this data in our read back, whatever it is, read back data lists, read back data lists, right? And as you see, it's a list of tuples where each tuple is a row. Each tuple is a row. And that's nice because we are totally getting back all the data that we have inserted. So imagine if you have power failure and you run Python again and it's able to read back from that file that it has safely committed. Now, what happens if we didn't commit? Okay, so let's again delete accounts and then we run. So when we didn't do that, in this case, we are lucky because the interface assume that we are able to we are not making changes, and so we are able to somehow enjoy the outcome because it was pretending to have inserted all this data. When we read it, it's saying that, well, if I had created and inserted all this data, I ought to have been able to read back, right? So I read back yes. Okay, and so I didn't do a commit. Let's look at what is inside the accounts using SQLite. Okay, so now we look at accounts. There's table, there's accounts, right? And we look at the details. The schema is nice. And we look at the data. Oops, no data, no data. What happened? Let's refresh. Ooh, no data. That means, in other words, we got fooled by the interface because the interface was pretending that this virtual environment, that if you had done this, there will be a table. If you have inserted, then there will be data. If you had read back after the insertion, had it been successful, you would have gotten back the entire data. And that's why you see all the read back data lists having the right data. But did you commit? No. So the actual database is still intact, and then you say close. Okay, fine. And what happens when we re-inspect this actual database using a different software or even with a actual Python script running again, you will find that nothing is there. So um, we keep this account. Let's delete it, and we re-enable the commit. Okay. Oh, sorry, I shouldn't save it. I want to delete this off later on. So let's run this. Okay, so everything looks the same because up to here, everything is based on virtual environment, pretending. Then actual commitment to the database. Everything is flushed into the database. It's now permanent. Then we read back. And of course, this time around, it's actually reading back. No more pretending. So even though we can't tell a difference between the non-commit and the commit, when we open up the actual database, something is different. Okay, so we look at the accounts, everything looks okay so far, and we look at the data. Aha, the data is there. Even though we are not accessing using Python, we can see that it is done. It is there. It is accessible by other software, more importantly. And remember, I could be running this simultaneously while programming with Python, and they will live happily with each other, right? Because they are accessing and you haven't committed, because I want SQLite Studio to be able to either see all these 10 rows or don't see. I don't want it to, at the right moment when I refresh, I see row 1 and 2, and the rest haven't been updated yet. And then I wait a while, I refresh again, it will see rows 1 to 8, but not finished yet. I know it's not correct. I want it to be able to see everything or else don't see anything. So that is a very important characteristics required in many commercial applications, such as bank ATM updates and subtract from money from this account and add into that account transfer. So you want the whole thing to be atomic, right? So you commit only when all the instructions are given, or else you don't commit. So this is exactly what is very nicely and in a very high integrity supported by SQLite. Okay, so I hope you have enjoyed this part and understood this part well. And from here on, basically remember the 4 color sections. You should be uh, basically enjoying a lot of happy coding with SQLite and Python interface. So see you in the next video.